some vectors, some histogram joy. So first one is just a little bit of problem solving, not too technical. You've got to use all this information here that you're given. So the bar representing 3 to 5 has a width of 1.5 and a height of 6. So you needed to be thinking about. Let's just draw a bar, shall we? It's got a height of width of 1.5 and an area of 6. So that gives it an area of 9 centimeters squared. Okay. So that is representing 12 people. Okay, so 12 people representing 9 centimeters, or 9 centimeters representing 12 people, means that each one person, loads of different ways of working this out, is equal to 3/4 of a centimetre squared. Then we need to think about this next bar along. Well, remember the group width. This class width is 2.5 to 5.5, so this has a class width of 3. So this one, going from 5.5 to 10.5, is slightly wider. So if this one had a class width of 3, and we drew it with 1.5, this one's got a class width of 5, you can pretty much see straight away, I just need to halve that. So the width of this rectangle needs to be 2.5. So we need it to represent 10 people. So 10 people, this area needs to represent. So 10 times 3/4 is 7.5 centimeters squared. So what do I need to times 2.5 by to get 7.5? 3. So I get 3 centimeters tall. Okay, so not too shabby. You just got to get your head around it. But if it wasn't there, you need to remember you've got to be quite determined and keep pushing on with the next question. Use some linear interpolation to estimate the median. Remember, the median is the middle value. So because it's over 30, you can just say 50 divided by 2. So I'm looking for the 25th person. You could do the 25th and a half person if you wanted to get the same amount of marks. So the 25th person, 16 people in that group. Running total gives me 28 in that group. That would give me 38, 46, 50. So the 25th person will be in this group again. This is the all-important group that we're dealing with. So 25th person, there's 28 in there, so I really, 25 minus 12 means, not 12, sorry, 25 minus 16, because I don't care about those first 16 people, means I need the 9th person in that group. Okay, so my lower class boundary is 2.5, plus I want the 9th person out of the 12 in those group, times by the class width. And remember, the class width, we talked about it here, was 3. Number crunch that, put it in your calculator, 4.75 distance travelled to work, so it would be kilometres. You could have, and a few people did the alternative kind of formula where you just do the formula, but a few of you just mocked it up. X minus 2.5, 5.5 minus 2.5. So that's looking at your class boundaries. 25 minus 16 over 28 minus 16. Again, hopefully you get the same answer. A little bit of tolerance on this answer if you'd use 25.5, but either way, all good. Okay, part C. Show that the estimate of the mean distance travelled to work is 7.88 kilometres. Only 1 mark for this. You should know that the mean is the sum, all the values divided by how many values, and there were 50 things looked at. 7.88. You need to learn your formulas for mean and standard deviation, especially as the next bit is calculate standard deviation. Standard deviation, you need to do 6500 divided by 50. Some of you missed that 50 off. Take away the mean squared, square root of that, so you get a standard deviation of 8.24. describe giving a reason, whether it was positive or negative skew. So only 2 marks, so normally one calculation or one thing to validate it, and then a conclusion. You've got the mean is 7.88, and you've got the median 4.75. So you can see your mean, 7.88, is bigger than your median of 4.75. If you remember, these are written in alphabetical order and they're pointing towards the positive end of the number line. So this is positive skew. A few of you wrote down that it was positive skew and wrote this statement, but had the arrow going the wrong way despite having these 2 numbers. So just be careful. Positive skew. Without any further calculations, state, give me a reason what effect adding another 7.88 distance journey would have to the mean, median, and the standard deviation. So someone did mean, median, mode because they clearly weren't concentrating. The mean, if you add a number that is exactly the same to the mean already, this will have no change on the mean. It will stay the same. So as it's the same as the mean, as same as the mean. No change on the new mean as it's the same as the old mean. Something like that. So no, the data isn't getting increased or anything like that. Median. Okay, will it change the median? Yes, it will. It will increase it. Look, the median was at 4.75. This number is bigger than the median, so the median will increase. As bigger than the old median. Gets spread further apart, or gets dragged further up if you like. And the standard deviation. So because this number is the same as the mean you had before, remember basically what the standard deviation does, it looks at all the bits of data and it measures how far they are from the mean. So if you've got all the data, if all the data was the same, the standard deviation would be 0. So would it be 1? Anyway, it'd be pretty small. So if this number is the same as the standard deviation, you're not increasing how spread out the data is. You're decreasing it. You're making them all close together. So this would decrease the standard deviation. Because the total amount of spread from that deviation is decreasing. Okay, they're actually getting closer together. Total amount of spread, run out of space, is decreasing. Banana.